Good day, viewers. You are welcome to Chemistry Hangout. I want to believe you are fine from anywhere you are watching me from. Welcome to another educative video on Chemistry Hangout. You are just watching this channel for the very first time. Please click the subscribe button and turn on the notification bell so that when I upload any video, you are going to be notified. For all my subscribers, for all my Chemistry Hangout family, all my subscribers, I will say thank you for the encouragement, thank you for your prayers, thank you for your motivation. I really do love you guys. Today again, we're welcome, and it's another wonderful episode on Chemistry Hangout. If you are preparing for JAM, take a seat and listen attentively to this video, and make sure you watch this video to the end. You are writing WAEC, you are doing IGM, you are doing any form of exam, please pay maximum attention to this video. And I've said that as time goes on, I'm going to bring you a lot of questions because I want to be showing us how to answer a whole lot of questions. So, but if some of the things we are doing on this channel are new to you, it means you are new to this very particular channel. So check other videos because we like to build our intensity. If you are doing a particular topic, I like taking us from, from the scratch, from the background, so that we understand. So most of the things we do here are continuation of what we have done before. So if the video seems confusing, then you have to check other videos so that you can understand and flow with us, so you get to understand what we are actually doing. So I'm going to bring you another question to you guys today, and I'm going to be explaining how we are going to be solving it. How you need to solve it is important. And we have noticed that even a lot of students, they know the question or they understand the topic, but how to actually answer the question is always a problem, which is what we actually want to tackle on this channel. So today, I have another question for you. So sit down, pay attention, watch this video to the end. You can share, comment, ask your questions, and I'll try as much as possible to get you, understand what we are actually doing. I will reply as much as possible. Though there are a lot of messages, but I'll try and reply as much as fast as possible. So let's see what we have today. Look at this question. This is another question for today. An element X has atomic number 12. Okay, write down the electronic configuration of X using SPDF notation. If you remember on this channel, we have done all this very particular, we have done all this topic. And one of the topics we have done on this channel is the rules that guide, the writing of electronic configuration. If you remember, 3 rules, very important: Hooke's rule, Pauli exclusion principle, and the alphabet principle. We have, we have dissected it. We have solved questions on it. I have explained them. So if you have not watched that video, kindly go and watch that video. So, and the reason why they were specific here, if you look at the question, they were specific. Because if they ask you to write electronic configuration, most times you can write in the shell form. That's the KMN from like 281, 282, and you should understand that. And for orbitals, you are 1s2, 2s2. However, in an exam, in a theoretical question or in a theory question, they ask you to write electronic configuration. It is better to write it in this format because this is the new electronic configuration. This is the modern electronic configuration. But thank God for this question, they are specific. But for an exam, even if they are not specific, they said write down the electronic configuration. It is better to use this because it is more detailed and it is the modern electronic configuration. I hope that is clear. So we can quickly do that now. Number 1, you can actually do that very, very fast. You have done all this rule before. You can check other videos. You can check it. That's sub-level and energy level. You can check them. It's on the channel. So for this one, since we already know that the atomic number is 12, then you can agree with me that the electronic configuration is going to be 1s2, 2s2, okay, 2p6, then we have 3s2. Correct. So the electronic configuration is going to be 1s2, 2s2, 2p6, and 3s2. So if you count this, 2 plus 2, that's 4, 4 plus 6, that's 10, 10 plus 2, that's 12. Correct. Because they've already told us that the atomic number is 12. So question 1 is clear, very clear. I want to believe it's clear, very, very clear. Okay, so they said state the group and period to which X belongs in the periodic table. Did you remember my last video? I brought a periodic table and I was explaining the features of the periodic table. If you remember, if you have not checked that video, go and watch it. You have not watched it. I brought a periodic table and I was explaining how do you get the group and how do you get the period. And if you remember, I told you, I said for you to get the group of an element in the periodic table, the number of valence electron in the outermost shell, how that's clear, is the group. Why the number of shell is the period. What am I saying in essence? Look at this. Let me use a particular element. Let's say, for example, I have carbon. The electronic configuration of carbon using the shell, you know, this 6, that's 2, 4. You understand? You should know all these 2. I've done all these over and over. So if you check the valence electron outside, is how many? Is 4. So that symbolizes the what? The group. Why the period is the number of shell. How many shell is this carbon having? Let me draw this so that you know the copy. How many shell is 1 and is 2? That means the period is going to be what? It's going to be 2. Do you understand that now? So which means carbon will be in group 4, then period 2. But now they've told us already that the atomic number of this one is 12. So 12 is going to be 2, 8, 2. Can you see that? So what's the valence electron here? The valence electron here is 2. I hope this is clear. The valence electron here is 2. Why the number of shell? This is the first shell, this is the second shell, this is the third shell. So which means this will be in group 2, period what? Period 3. Can you see that now? So very correct. So number 2, the answer to number 2 is state the group. So the group will be group what? As we have said, group 2. Then we have period what? 3. And how is it period 3? The number of shells, this very particular element that has 12 is going to have is 3 shells. While the number of valence electrons that will be outside will be 2. So the number of valence electrons outside is this 2, and that forms the group. While the number of shells, okay, is this 3, that forms the period. I want to believe this is very, very clear. So chemistry is very interesting. Just get the basics. Get the basics. And the reason why I'm so specific about this question is because you cannot escape questions like periodic table in any exam. As far as chemistry is concerned, periodic table and bonding, periodic table, electronic configuration and bonding are 3-in-1 questions. So you cannot escape it. That's why I'm doing a lot of examples on this. Okay. So number 2 is sorted. Number 3, they said, how many electrons are present in the ions of X? Please pay attention to this. Very technical but simple. How many electrons on the line are present in the ions of X? Can you see that? And what is an ion? A group of atoms that has charge. Can you see? So which means what will happen? If you remember atomic number, the definition, they said atomic number is the number of protons, and the number of protons is equal to the number of electrons in a neutral atom. There is a clause there. So the number of protons will only be equal to the number of electrons if the atom is neutral. But now the atom is not neutral. Can you see? It's not an ion. Which means that from my valency video, I have done that video on the channel. Can you see? There are actually a lot of questions. From my valency video, I told you, in as much as this is 12, what happens? This is 2, 8, 2. The tendency that it will give out 2 is high because it has not completed what we call the octet or the duplex structure. So what happens? It will give this 2. So when it gives this 2, it becomes stable. So which means that your X have tendency to give 2, and when it gives 2, it becomes 2 plus. I have done these things in valency. Okay, so how do I know it is going to give 2? From the electronic configuration 282, it has not attained duplex or octet structure. Okay, it gives 2, and when it gives 2, it becomes 2 plus. Do you see? So how many electrons do you add here before? That's 12, but now it has given 2. Do you understand? Because the S here, which is 282, is neutral. It's not carrying charge. But now as it gives its 2, it becomes 2 plus. So it becomes 2, 8. How? Because it has what? It has given out this 2. So this is now and what? An ion. I want to believe this is clear. So the answer, how many electrons are present in the ions of X? How many electrons? So since it becomes, for it to become an ion, it has to give 2. And when it gives 2, the what? The electron will change, because when it is neutral before, the protons and the electrons are 12, but now it has given 2, so the number of electrons becomes how many? Becomes 10. How? Because it has given 2. If it has collected meaning it will increase. But because it has given, it means it will decrease. So here they said how many electrons are present in the ions of Earth. So the number of electrons that are present will be 10 electrons. Why will it be 10 electrons? I have explained. Since it is an ion, it has tendency to give 2. So when it gives this 2, it becomes 2, 8. It will be stable, and the number of electrons will become what? Will become 10. So it is 10 electrons. Because again, a lot of students will still record 12. Yes, but there is a clause, an ion. So if it is an ion, it means it has carried charge. And if it carries charge, what is the tendency of charge that it is, it has tendency to carry? It is positive. Why? Because of this, I have explained all this in valency. So if it gives 2, it becomes 10 electrons. I hope that is clear. Number 4. And you can see the application of, look at this question. You can see the application of periodic table. You can see the application of electronic configuration. You can see the application of valency. You are still going to see the application of trying to combine valencies together, which is a series of videos I did on the channel. It's still there. How to name inorganic compounds. I did 3 or 4 videos about that. You understand? I did about 4 videos on that. So all these things are embedded in one. So you have to have the foundational knowledge of these things to be able to answer this question. Now look at this again. They said write the formula of the chloride of X. From that word, chloride. Chloride is just like a dual compound. It's like a dual compound. Dual compound means you have chlorine plus a particular element. That's the meaning. So you have chlorine and a particular element. So how do I get the chloride? First thing, chlorine. Chlorine is what? Is 287. Do you still remember? Chlorine is 287. That's the atomic number is 17, and that's the KLMN electronic configuration. So what happens? Chlorine will have tendency to collect 1. So when chlorine collects 1, what will happen? Chlorine becomes Cl minus. Can you see that now? Chlorine becomes Cl minus. So if chlorine becomes Cl minus, these elements that want to react, because they said write the formula of the chloride of X. The formula of the chloride of X. So chlorine will become minus, and don't forget X, we already understood from the question before that S is going to have 2 plus. Can you see that now? So how will this formula look like? I told you that when you want to write compounds, what happens? They will exchange their valencies. So when they exchange their valency, I did that in my how to name an inorganic compound. X means 2, chlorine here means what? 1. When you cross multiply them, they exchange their valency, it becomes what? XCl2. Can you see that? XCl2. So number 4, write the formula of the chloride of X. It's going to be SCl2. Anybody that sees this will know that it is X that has this very particular 2. Why chlorine is having 1? That's why this one is not carrying any subscript that you are seeing. Okay, so the formula of the chloride of X is going to be, it's going to be 2, SL2. It's going to be SL2. So write the formula of the what? Of the chloride of X. This will be it. So let's go to number 5. Let me get my duster. Get this. Okay, so very, very important. You have to understand that. Very important. So very, very important. You have to know all this. And you can see a lot of questions coming from here. They say state the type of bond present in the chloride of X. Very simple. I have talked about bonding on this same channel. I did electrovalent, I did covalent, I did coordinate covalent, I did metallic, I did hydrogen bond, I did van der Waals. A simplified video on them. So how do we know the kind of bond that is formed between this? Very simple. Do you remember that what brought about this is what? S2 plus Cl minus. This is what brought about them, right? And what is this? Positive and negative charge. Positive charge and negative charge. Can you see that? So when you have a positive charge and negative charge like this, the kind of bond that will be formed will be either, we call it ionic or electrovalent bond. Okay? The kind of bond that will be formed will be ionic. That's why they said it's ionic. What's the meaning of ionic? An ion. These are ions coming together. Can you see? An atom or group of atoms that carries charge is what we refer to as an ion. Do you see that? So this very particular compound is formed from, you know, different ions coming together, and that's where the name came from, ionic or electrovalent. Electrovalent means extra or, you know, leftover electrons. That's what they use, and that's why we have that. So very simple. Go and check electrovalent bond. You know, I explained that that's the transfer of electron from metals to non-metals. I've explained all that in the video. So let's see the last one. They said suggest 3 property expected of the chloride of X. Can you see? Suggest 3 properties expected. What are the properties we expect? The chloride of X, since we know that the kind of bond is electrovalent or ionic, then the kind of property that we exhibit is the electrovalent, which implies that if you have failed this, maybe you wrote covalent or you wrote coordinate covalent, it means the property you are going to be giving them will be that, and you will be very, very wrong. Can you see? So these things are stepwise, they are sequential. So you have to understand, because if you miss one, you can actually miss the other, because the question they are asking is just like a prerequisite. It's just like if you don't know this, you cannot be able to answer this. So since this is an electrovalent bond, it means that the property of this very particular chloride will be the property of electrovalent compounds. And what are the properties? Number one is they have high melting and boiling point. They have high melting and boiling point. That's number 1. And boiling point. Number 2, for electrovalent compounds, they are solid, most times are solid at room temperature. They are solid at room temperature. How many reactions to give? I have a lot of them, so just 3, okay? So another one that we know electrovalent compounds for is that they are good conductors. They are good conductors of heat and electricity. Yes, they are good conductors of heat and electricity. Another one we can give, you know, they said 3, so I'm just giving that so that you have, you know, you have a lot of properties. They are soluble. They are soluble in polar solvents. They are soluble. We have a lot of them like that. So why am I able to get all this property? The reason why I'm able to get all this property is because I already understood that the kind of bond between them is this. So I'm giving the property of electrovalent bond, and that's such a question. Please take note of this thing. Look at this question now. This question has tested your knowledge on electronic configuration. Can you see that? This question has tested your knowledge on periodic table. This question has tested your knowledge on chemical bonding. Can you see that? This question has tested your knowledge about properties of some chemical bonds. So that's the reason why I'm taking this approach. Because a particular question might stretch you to understand the 3, 4, 5 topics in chemistry, and that's what you are going to put together to be able to answer this. So you can watch this video over and over and over again. For some people that wish to write, you can just, you can take the video back, just try to rewind back, okay, and write the question, then you can follow the answers I did. You can follow the answers I did. So very, very important. These are the questions, and these are the answers to this question. So you can use this to prepare. You are a jumper, you can use it to prepare. You are preparing for WAEC, you can also use it to prepare. In fact, if you are in SS1, you are in SS2, you are in any of those classes, these are things you would have done. SS1, you must have done electronic configuration, and all these questions like this will build your intensity and confidence in this subject called chemistry. So that is that. Just take time to watch the video. You can share it to your friends, you can comment, like the video, and we are still going to be back here all the time to give us informative videos. If you are writing JAMB, I have said that before on this channel, there is a link in the comment box section. You can join the ongoing classes. It has started since the beginning of this month, and it has been interesting so far. And it's for science students only anyway. If you're a science student, you can join them so that you can participate in that very particular class too. And for my co-educators, chemistry teachers, okay, we want to believe you are preparing your student for WAEC. And if you are finding anything difficult as regards practical, there is a step-by-step video that a lot of chemistry teachers have gotten access to. It is prepared by me, all to the glory of God, and a lot of teachers have gotten access to it, and the review has been amazing. The review has been awesome. So you are finding any practical difficult, especially preparing laboratory reagents, working with those things and trying to prepare a particular specification, you are still finding some a little bit of a problem there, you can always click the comment box section. There is a link I'm going to drop in the comment box section. You can click it, read what is there. If you feel the video will be beneficial to you, then it's going to link you to where you're going to get the video. So I love you guys. If you are just watching this channel for the very first time, do well to subscribe to this channel, share the video, comment, like the video, and we're going to be back here another time for another wonderful chemistry teaching. So I love you guys. Thank you so much. Have a wonderful day. I love you. Thank you.